The sun is the superpower of our solar system. A thermonuclear blast furnace erupting with massive explosions.
It can be the same amount of mass as Mount Everest coming out from the sun and flying out into space.
At 93 million miles away, it would seem that we're safe from the sun's wrath. But are we?
It matters, especially in modern times, what the sun is doing.
From the center of the sun, as it rotates around, is the kill zone.
With some experts predicting the most violent outbreak of solar activity in modern history, it's never been more important to understand the secrets of the sun. There are billions of stars in the universe, but one alone dominates our cosmic neighborhood: the sun. It's an infernal sphere of mostly hydrogen and helium, superheated into a plasma that burns at millions of degrees. Its surface rages with violent explosions as it spews out storms of deadly radiation millions of miles into space. Our sun is a type of star known as a yellow dwarf. Yellow because of the color of its surface, and dwarf because it's small for a star. But small is relative. Within its boundaries, you could fit 1 million Earths. In our solar system, there's simply no bigger star than the sun. At 1 million miles across, it's a massive celestial blockbuster.
The sun is really pretty huge. It dominates our solar system. Not only is it the biggest star in the solar system, it's the only star in the solar system. It's surrounded by a bunch of smaller stuff that we call planets and comets and moons. But the sun is our star.
Our star is an enormous source of heat and energy. It has a surface temperature of 10,000 degrees Fahrenheit and generates 380 billion megawatts of power. This dwarfs anything on the human scale. Hoover Dam in Nevada only generates 2,080 megawatts. In 1 second, the sun churns out more energy than has been used in all of human civilization. All that power in the blink of an eye. Incredibly, it's been burning this way for billions of years.
Early astronomers didn't quite understand how the sun could generate so much energy for that long a period of time. That was the first mystery, was really how the sun generates its energy.
In the early 19th century, scientists assumed that the sun worked just like any fire on Earth, that there was a source of fuel, perhaps coal, that was slowly burning away. But there was a serious problem with this theory.
I've got a fire in front of me here. If I want it to keep burning, I have to keep adding wood to it. This fire will last maybe an hour unless I add some more wood. Now, if I had a pile of wood the size of the whole sun and somehow enough oxygen to burn it, it would only take about 5,000 or 6,000 years to burn out. That's a long time, but it's not long enough to sustain life on Earth.
By the early 20th century, carbon dating of Earth rocks and fossils had proven that the sun was in existence and at temperatures warm enough to sustain life, not for thousands of years, but for 3 billion. If you wanted to build a fire that would last that long, you would need 72 trillion cords of firewood. That's 12,000 cords for each man, woman, and child on the planet. Clearly, there had to be some other process unknown on Earth that was powering the sun. In the 1920s, scientists found the answer to the puzzle in a process that would later be harnessed to fuel the hydrogen bomb: nuclear fusion. Fusion occurs when atoms are smashed together at a high rate of speed and literally fused. To get this to happen, conditions have to be just right.
For any interaction to happen, these two protons each has a positive electric charge, and so they would repel each other. So you've got to get them close enough together. And to do that, it's got to be hot, which means the particles moving very fast, and dense enough that they hit each other and they can get close enough together that they actually fuse.
The core of the sun is the perfect cauldron for nuclear fusion. It's the hottest place in the solar system at a sweltering 27 million degrees Fahrenheit, and it's also incredibly dense.
It's so dense, it's 10 times the density of lead. And you would think at that density it should be a solid, but it's not because it's so hot that it remains a plasma.
If you heat a gas to high enough temperatures, electrons fall off of the atoms and they float around in the soup. And so it has behavior that's different from what a gas would do. And so we have a different word for it, call it plasma.
To truly understand what goes on in the core of the sun, you have to find some way to imagine the almost unimaginable.
In addition to studying the sun, I also play pool. And the sun is a place where there are billions of particles colliding and interacting with each other. And it's really not unlike a cosmic pool table on an unimaginable scale. It doesn't matter how hard you hit a ball. You would never hit it hard enough to actually fuse that ball together with another ball. But there's so much pressure and such high density at the core of the sun that the two objects impacting each other will actually fuse.
In the sun, these objects are hydrogen atoms flung together by immense pressure to form helium atoms. In this fusion process, the resulting atom is slightly less massive than the ones that created it. The missing mass is given off as energy. Each second inside the sun, 600 million tons of hydrogen are fused into 595 million tons of helium. That 5 million tons of mass lost in the process is converted into energy equal to 1 billion 1 megaton hydrogen bombs. That's every second.
When you look out into the cosmos, the process that gives you the highest return of energy for free is what goes on in the centers of stars like the sun.
So we now know that the sun is powered by nuclear fusion. It's the only fuel that we know that can sustain the burning in the sun long enough to sustain life on Earth, billions of years.
Sunlight. It's so central to life that we don't often give it a second thought. But how light gets from there to here turns out to be an incredible story. The energy created in the fusion process is carried out of the core by particles of light and heat called photons. They are what bring the warming rays of the sun to Earth. To reach our planet, these glowing travelers from our nearest star must first take a long, winding road through all the layers of the sun, like Dante journeying through the levels of hell. First, a photon enters the 185,000-mile-thick radiative zone. The region is so densely packed that the photon constantly bumps into other particles, like hydrogen and helium atoms. It struggles outward in a chaotic zigzag pattern that scientists call the random walk.
A photon can't escape without interacting over and over and over and over again, getting absorbed by atoms and re-emitted, and it can be absorbed and re-emitted millions of times. As the density decreases, as you get further up in the sun, it becomes easier, and the collisions and the interactions are less.
When it finally reaches to within 130,000 miles of the surface, the photon enters the convective zone, and the pace suddenly quickens. It's carried upwards by a kind of boiling, riding along in huge columns of gas at hundreds of miles an hour, taking only 10 days to emerge on the solar surface. The incredible journey is almost over as the photon lifts off through the wispy gases of the solar atmosphere. From there, it takes only 8 minutes for it to zip across 93 million miles of space to our planet. Incredibly, by the time sunlight actually reaches Earth, it's already been in existence for hundreds of thousands, if not millions, of years. For the sun, even 1 million years is a small blip in time. The simple, perfect disk of a sunset belies the long, violent history of our star. It is a ball of fire spawned billions of years ago in a massive explosion known as a supernova.
After this titanic explosion, where a star much larger than the sun exploded, there would have been a huge cloud of gas, many times larger than the solar system. And small knots of material would have gradually coalesced in this very large cloud.
About 5 billion years ago, some 10 billion years after the Big Bang that scientists believe kick-started our universe, this cloud started to collapse under the pull of gravity.
Our solar system probably arose from one such knot of self-gravitating gas that pulled itself together and gradually spun itself up as it pulled in, like a skater pulling her arms in during a spin, until the star and the various planets coalesced around it. Ultimately, when the star was dense enough, it would have turned on fusion and started glowing, giving off sunlight.
Why do scientists believe the sun was born from the ashes of a supernova? The evidence lies beneath our feet. Complex, heavy elements like the uranium we mine from the Earth to fuel our nuclear power plants could not have been forged in the sun. There is simply not enough heat in a star that size to create elements any heavier than iron. Heavy elements like uranium can only be created in a catastrophic cosmic explosion. Earth and the other planets in the solar system formed out of the same knot of gas that produced the sun. In this process, the sun hoarded 99% of the mass. This means it's the biggest object in our celestial neighborhood with the strongest gravitational pull. That's why everything else revolves around it. Of all the planets, Earth earned a privileged place in relation to the sun. If we were closer in, our oceans would boil away and the ground would be hot enough to melt lead. If we were farther out, our planet would be a frozen wasteland.
Sort of like Goldilocks and the Three Bears. Not too hot, not too cold, it's just right. Here we are at about 93 million miles away from the sun, and we're happy to be here. We're lucky to be here. And in some sense, we're here because it's the right circumstance for us to be here.
Earth may be in just the right place in the solar system, but we're also close enough to the sun to be a target of its fury. Thousands of mammoth explosions rock our sun every year. You might expect this explosive force to come from nuclear reactions in the core. But in reality, what drives all outbursts of solar violence is magnetism. Since Earth rotates as a solid, our magnetic field is simple. We have two poles, north and south. This is what makes a compass so useful for finding your way around the planet. But imagine if instead of two poles, you had 1 to 10 million. This is what happens on the sun. The sun's magnetic field is a tangled web because even though it's held together by gravity, the plasma doesn't rotate evenly. Plasma at the equator rotates once every 25 Earth days, while plasma at the poles takes roughly 35 days to circle once.
The sun has what we call differential rotation. You have all of this plasma that is really turning and churning, and that causes magnetic field lines to become twisted and intertwined and mixed up.
Although magnetic field lines are invisible, we know they exist on the sun by looking at features called coronal loops and prominences rising up into the solar atmosphere. Just as metal shavings line up in the presence of a simple magnet, these loops of plasma perfectly outline the magnetic structures that support them from below. These plasma arches are so tall and wide that you could slide a planet as big as Jupiter right through them. Sometimes magnetic fields can twist plasma in the sun's atmosphere into majestic helical shapes called flux ropes.
Magnetic flux rope is sort of like a slinky. The magnetic field line is wrapped around many times in a helical structure. And when you have highly twisted magnetic field lines, it carries a lot of stored free magnetic energy. And sometimes it will even kink in on itself, which gives it even more stored magnetic free energy.
These plasma prominences can last for weeks or months, but eventually the stored up energy has to be released, and the mass is flung off into space. Where the sun's magnetic field is at its most twisted and complex, heat bubbling up from below is capped, and the material is cooled by as much as 1,000 degrees. What results are relatively dark blemishes on the solar surface called sunspots. Sunspots are only dark in relation to the bright material around them. If you could somehow suspend one alone up in space, it would shine 10 times brighter than the full moon. These apparently tiny blemishes are actually plasma craters the size of the entire Earth. Galileo was one of the first modern scientists to observe sunspots. Using a telescope, he projected an image of the sun onto paper and traced it. He realized that the blemishes were moving across the face of the star, which was the first indication that the sun rotated. Not only does the sun rotate, but sunspots themselves can actually spin like hurricanes on the solar surface. And when they do, their magnetic field lines become extremely twisted. Twisted magnetic field lines mean more energy, and more energy means the potential for huge eruptions.
Think of a rubber band as a magnetic field line. If you twist it, and you twist it enough, it's going to have all that energy, and when you let it go, it's going to release. If you just take an untwisted rubber band and release it, it's not going to fly.
When a sunspot unleashes its magnetic energy, what results are the most colossal explosions in the solar system: solar flares. A single flare releases as much as 1 billion megatons of energy, the combined power of 1 million volcanic eruptions on Earth.
They appear as these very bright regions, and they're so bright because the temperature is so high, on the order of 10 million degrees. And they can last for hours, but the energy is massive.
The whole explosion is equivalent to millions of nuclear bombs leaving the surface of the sun all at once.
Solar flares don't just explode out into space. They also funnel high-energy particles down to a layer of the sun called the chromosphere, where they quickly transfer their energy like a cue ball striking the rack in a game of billiards.
So the cue ball acts like one of these very high energetic particles coming from the flare region. The cue ball smacks very quickly into the 8-ball rack. And once it impacts that head ball, it's going to transfer that energy to the balls behind it, and then they will all fly out because the energy is transferred to all of them.
If a large flare shoots enough high-energy particles at once, strange things start to happen. This is actual footage of a sunquake.
In 1998, there was a solar flare up in the corona that was so powerful that the material flying down toward the surface of the sun actually slapped the surface and caused ripples to spread out from there.
While they may look like ripples on a pond, these are actually waves 2 miles high, traveling at a maximum velocity of 250,000 miles per hour. The 1998 sunquake would have measured an 11.3 on the Richter scale, more than 1 million times stronger than the 1989 earthquake that shook San Francisco. In order to shake the surface of the sun that much, the solar flare had to release a colossal amount of energy.
It turns out it's almost the same amount of energy as if you covered the entire landmass of the Earth with dynamite, about a yard thick, and set it all off at once. So these explosions are not small.
Earthquakes aren't the only natural disasters with equivalents on the sun. A flare can also kick off a solar tsunami. as waves of plasma in the sun's atmosphere rocket out at 700,000 miles per hour, spreading around the entire face of the star in a matter of hours. While sunquakes and solar tsunamis pose no danger to Earth, the violent action of a flare frequently triggers dangerous eruptions called coronal mass ejections, or CMEs. In a CME, energy from a flare flings a blob of highly charged radioactive plasma out of the solar atmosphere.
Coronal mass ejections range in speeds, but they can occur as quick as 800, 900 miles per second, which is extremely fast, and they expel a massive amount of material. It can be the same amount of mass as, say, Mount Everest coming out from the sun and flying out into space.
Where does this blob of superheated radioactive plasma go when it leaves the sun? Sometimes it sails out harmlessly into space. Other times, it may head closer to home. Coronal mass ejections from the sun are perhaps the most dangerous threat you've never heard of. Also known as solar storms, they hurl large masses of supercharged particles across 93 million miles of space. Most take several days to travel from the sun to the Earth, but some rocket across the solar system at up to 6 million miles an hour, reaching our planet in less than 16 hours. These storms can induce currents in the outer atmosphere, knocking out satellites and cross-country power grids, and carry the potential to wreak just as much havoc on our infrastructure as a hurricane or tornado. But who on Earth is keeping an eye on these potentially hazardous cosmic blasts? This is the headquarters of the National Oceanic and Atmospheric Administration, home to the U.S. government's National Weather Service. Their daily forecasts, watches, and warnings are essential information for everyday life on our planet. But there's a lesser-known group of forecasters working here in a special division called the Space Environment Center.
Our primary job is to monitor the sun and to put out the alerts and watches and warnings for solar activity.
Good morning, welcome to our 810 briefing. We had one long-duration C flare from the East Limb. That's possible CME. We have not had protons, but we have had electrons.
One thing to note is that this region produced all the activity in December, so things might be picking up here in the next couple of weeks.
These space forecasters are on high alert for solar storms that might disrupt life on Earth. Solar storm clouds are made up of charged particles, so they're initially diverted around the planet by our magnetic field, just like waves breaking around the bow of a boat.
That turns out to be very important because if it impacted the outer atmosphere directly, it would knock little bits of the atmosphere off into space. One reason why Mars doesn't have an atmosphere is that it doesn't have a strong internal magnetic field. And so gradually, over millions or maybe billions of years, the atmosphere was gradually knocked off into space by the influence of the solar wind and by CMEs that came past the planet.
But our magnetic field is not the perfect force field of sci-fi movies. Some particles can penetrate it, charging up the upper atmosphere. Solar storms will even bend and break the magnetic field lines on the far side of the Earth, allowing charged particles to zip back down the field lines toward the North and South poles. Extremely powerful storms distort the magnetic field even further, inducing electric currents that span the continents. When this happens, technology like long-distance power lines can become overloaded.
It can cause damage to transformers at either end of the line. In fact, in 1989, most of the Canadian province of Quebec blacked out because a transformer was blown out by a solar event.
If we have that storm that hits our communication system, it hits our power companies and all these things that we depend on, there's all kinds of chaos that can lay out there.
If power operators have time to react, they can reduce the current being sent over their wires and avert disaster. Satellite operators can also prepare for the onslaught with proper warning.
When there's a big space storm coming, they'll actually put some of their satellites to sleep so that the storm doesn't cause an electrical short or otherwise somehow knock out the satellite. So the more warning time they have, the better.
We wouldn't go sailing unless we knew what the weather was going to be. Similarly, when we have a large system like a power system or a telephone grid that can be affected by the weather in space, we need to know what the weather is going to be so that we can try and mitigate it.
Solar storms can also disrupt high-frequency radio communications used by aircraft. In the 1980s, Air Force One was transporting President Reagan on a trip to China when a solar storm struck. All communications were lost for several hours, effectively severing the head of the United States government.
The urgency is just like our Earth's weather. When we have a tornado warning, we know the urgency to get that out to the public, to let people know that this is happening. The same thing is with space weather. Users of this information need to know it, and they need to know it now. Just a few hours back, we experienced a coronal mass ejection. We want to see where this blast is going out, and then we can measure that and see how long it might take from that to reach the Earth from the sun. We're seeing a very huge explosion of material that's coming out, and if you look at this small image here, here's the sun that's covered up, and look at the mass that's being thrown out into space. So it's huge, very huge.
Because magnetic field lines emanate from the North and South poles, energy from solar storms has easy access to those regions. For that reason, experts worry that airplane passengers flying over the poles during a powerful storm might be exposed to harmful levels of radiation, perhaps a dose equal to 100 chest X-rays.
It's not something that we want to mess around with because we never know when that radiation might all of a sudden become a lot more intense while there's an airplane in the sky.
The threat from solar radiation is just one more reason scientists keep a close watch on our sun.
It matters, especially in modern times, what the sun is doing. Earth is not an island. We are a participant in the activities of the solar system.
Sunspots are the triggers for most severe solar storms, so forecasters track them carefully as they rotate across the surface of the sun.
Location, location, location. We see coronal mass ejections all the time from the sun. A lot of them are as the sun is rotated around or from the backside of the sun. That would not be faced toward the Earth, so that would be less of a concern. As the sun rotates around and that active region gets more into the center of the disk, looking at us, then that's when we would be concerned with. From the center of the sun, as it rotates around, is the kill zone.
As the sunspot rotates around and begins to face directly at Earth, that's when we really have to worry about a storm. If a big storm lifts off then, it can aim directly at Earth and the full force of the storm slams into the planet.
It's like a shotgun aiming at a target. The more dead-on the shot, the more likely serious damage will be inflicted. With great danger also comes astonishing beauty. Solar storms generate majestic planetary light shows. The shimmering curtains of color called the aurora. Auroras work like neon signs on an enormous scale. In a neon sign, electricity introduces charged particles into a gas-filled tube. The particles in the gas are excited and start to glow. If the tube has only neon inside, it will glow red. By adding other gases, like argon, a whole range of colors can be produced.
The neon sign is driven by the electric field inside the tube, whereas the aurora is actually driven by the magnetic field and energy from the sun.
As the energetic particles in a solar storm stream along Earth's magnetic field towards the poles, they excite elements in our atmosphere, causing them to glow. Oxygen molecules emit a green or red color, and nitrogen emits pinks, blues, and violets. While these ghostly lights are usually confined to the poles, extremely strong solar storms can drive them closer to the equator. In 1859, a geomagnetic storm ignited by a huge solar flare created auroras as far south as Rome. The 1859 storm was an unusually powerful event that some have called the perfect solar storm.
The 1859 storm taught us a little something about what the sun can do. The storm was so intense and the alignment was so perfect that it simply overwhelmed Earth's natural defenses.
A huge solar flare erupts on the surface of the sun. Less than a day later, and 93 million miles away, the wires that carry communications across the Earth begin to spark. Business grinds to a halt worldwide as wildfires are ignited by the smoldering lines. At the same time, colorful auroras light up the skies of cities around the globe. Earth has just been visited by the perfect solar storm.
The sun kicked up this just incredible solar flare and a massive amount of energy headed towards Earth.
Not only was this storm one of the two most powerful on record, it was also one of the fastest. Ejecting from a sunspot aimed directly at Earth, it raced from the sun to our planet in less than 18 hours.
Now it takes a really fast rocket ship years to get to the sun. This storm, this cloud of electrified particles, managed to get here in less than a day. That's incredibly fast.
Fortunately, the perfect solar storm took place in 1859, when the only technology vulnerable to the onslaught was the telegraph. Since the era in which we have become dependent on high technology, we've yet to see another perfect solar storm. The question remains, could it happen again?
What if we have another one like that? Can we have another perfect storm? Well, I'd say yes, we can. There's no doubt about that. The effects that would be on us today compared to 1859 could be devastating.
The effects on Earth and on our communication systems, we don't exactly know. That's the scary part.
It's likely that our modern technologies would be battered like beachfront houses during a hurricane. Imagine if we lost all the satellites that relay cell phone calls, television signals, and bank transactions. And what if, at the same time, the failure of power grids cascaded whole regions into darkness for hours or weeks? If these essential services couldn't be restored quickly, chaos wouldn't be far behind.
It would definitely be a ripple effect upon society and every man and woman and child that lives on this earth.
Solar storms can be as hard to predict as hurricanes. While forecasters lack the technology to foretell the next perfect storm, they do know that one would be more likely to hit at the peak of the sun's 11-year sunspot cycle.
What happens is the sun reverses the direction of its magnetic field every 11 years. So in 22 years, it reverses and comes back to where it was.
As we near the reversal every 11 years, the number of sunspots increases, and there's a spike in solar activity.
We call that period solar maximum. And those periods are interspersed about 5 years apart from periods we call solar minimum.
So you have this 11-year back and forth between the sun being sometimes very ferocious and it goes crazy and it's like the 4th of July with fireworks all the time. And then it starts to ramp down, and for a few years it gets quieter until we get to a low point where there's a firecracker now and then, but not a lot going on.
Just like hurricane seasons, solar maximums vary in intensity. Some produce many more powerful storms than others. Although we're currently at solar minimum, scientists are watching carefully to see what mayhem the next solar max might unleash.
So the last solar maximum was in about 2001, and so the next one ought to be about 2012. But there are different predictions. The whole field of solar physicists is basically waiting with bated breath to see what actually happens.
There are some wildly divergent opinions on what's going to happen. One group is suggesting that this next solar cycle could be the strongest in modern times.
If those predictions are correct, Earth could be in for a wild ride.
We might have to worry about a repeat of the 1859 event. If that were to happen today, it would wreak untold damage.
We're going to learn a whole lot about what can happen to modern technology when the sun blows its top.
Much of the violence in the sun erupts here, in the hellish outer atmosphere known as the corona. This region has long held one of the great solar mysteries, because even though it's 500,000 miles from the heat-generating core, it burns at millions of degrees. This seems to violate the very laws of physics.
That's very strange. I have a thermometer here. If I hold the thermometer close to the fire, it reads a very high reading. Where the probe is right now, it's over 200 degrees. Now, if I pull the probe out a little farther from the fire, okay, it drops down to about 90 degrees. Now, the farther I get from the center, the cooler it gets. In the atmosphere, the corona of the sun, the temperature soars as hot as the core. That's as if I were to say, well, way off behind me there, the heat from the fire is as hot as the fire itself, even though it's very far from the fire.
What force could possibly cause the superheating of the corona? The answer will rock you. The hellish solar corona rages at millions of degrees. For centuries, scientists have been baffled how anything so far from the sun's core could still burn so hot. Recently, as improved satellites offered a closer view of the solar surface, clues began to emerge. Below the corona, the sun's surface is literally boiling.
The reason is that the entire surface of the sun is covered with convection cells, hot material from the inside of the sun that rises up through, reaches the surface, cools off by glowing, giving off sunlight, and then sinks back down. Each bubble of material that comes up is about the size of Texas. It spreads out across the surface, cools off, and sinks down in 5 minutes. So that's a tremendously violent process. Well, that's happening in literally almost 1 million places over the entire surface of the sun all the time, around the clock, 24/7.
This boiling isn't only violent, it's also extremely loud.
The sun is a tremendously loud place. If you could imagine covering the entire surface of the sun with speakers being driven as hard as the loudest rock concert you've ever been to, that would be comparable to how loud it really is on the surface of the sun.
The sun's churning surface creates enough sound energy to superheat the corona to millions of degrees. Scientists believe that a combination of these sound waves and energy from the sun's magnetic field is responsible for the extreme temperatures found in the corona. The only time you can actually see the corona from Earth is at the climax of one of the most dazzling displays in the solar system, a total solar eclipse. Before scientists understood them, these awe-inspiring events instilled only fear. The ancient Chinese believed that a dragon was devouring the sun. So what's really happening in a solar eclipse? In simplest terms, it's when the moon blocks our view of the sun.
Imagine that you're sitting in the movies watching very happily something going on the screen, and then somebody in the row in front of you comes across and blocks your view. In the movie theater, you might not want that person to come across in front of you, but at an eclipse, we're very lucky to have the moon come across the sun, and we're lucky to have it come right across the middle.
We're also lucky that the moon, although it's 400 times smaller than the sun, is also 400 times closer to us. This cosmic coincidence means that the two objects just happen to be the same apparent size in our sky, which allows for one to completely block out the other. This magnificent cosmic event only happens when the path of the moon intersects the line between the Earth and the sun. The moon's orbit is tilted slightly, about 5 degrees. If it wasn't, we would have an eclipse every month.
And then we'd be bored. But we're not bored because most months the moon goes above or below the place where the line goes from the Earth to the sun.
So instead of one every month, we get a total eclipse somewhere on Earth about once every year and a half. As the moon slides in front of the sun, it casts a shadow onto the Earth. The outer part, where the shadow is fainter, is called the penumbra. If you're standing within the swath traced by the penumbra as it moves along the Earth's surface, then you'll see only a partial eclipse. But travel to a spot within the path of the dark inner shadow called the umbra, and you'll experience the majesty of a total eclipse. There's another option if you can't travel to the path of totality. Wait in one place long enough, and a total eclipse will pass right over your head about once every 300 years. The sun, that shining star of our solar system, is capable of both astonishing beauty and ferocious violence. It seems impossible to believe, but it won't be around forever. Eventually, even the sun must die.
The sun has a fixed amount of fuel in its core. It is undergoing fusion at a rate that you can calculate. You say, here's the rate it's using its fuel. Here's how much fuel you have. So it's a simple calculation to show when the sun will die. And that's in about 5 billion years.
Well, unfortunately, the sun will not go out with a bang. It is too small to erupt in a supernova. However, stars do a peculiar thing. They're one of the few things around that get hotter as they cool off.
As it exhausts its hydrogen fuel, our nearest star will cool and gradually collapse under the force of gravity. Energy from this collapse will start heating up the core again to hundreds of millions of degrees, hot enough to start burning helium. Under the extra heat of the helium burning, the star will expand into a monstrous orb called a red giant.
It gets so big, it will engulf the entire orbits of Mercury, Venus, and Earth. You don't want to be around for that. You want to be planet hopping your way to safety long before this happens.
The Earth is likely to change its orbit slightly as the star expands so that it won't be engulfed. Still, talk about global warming, you wouldn't want to be there.
The outer layers of our sun will eventually become so unstable that they will fly off into space, leaving behind a small core about the size of the Earth.
So remember, we've shrunk most of the sun, which is 1 million miles across, to the size of the Earth, which is more like 6,000 miles across.
Our once great star reduced to a slowly cooling cinder.
And life as we know it on Earth will cease to exist. And that is the death of the sun.
All of this is bad news for the human race. But look on the bright side.
We've got 5 billion years to prepare for this disaster.
For now, humanity basks in the glow of a sun in the prime of its life. Science has uncovered many of the secrets of our nearest star, but we remain awed by its beauty and ever more wary of its wrath. It takes its name from the Roman god of war, a distant, rusty orb in the night sky, a source of rampant speculation for centuries. Could it be home to a rival civilization? Is there really a face on its surface? this intriguing planetary neighbor still captivates us. And as both a potential base for future colonization and the keeper of 4 billion-year-old biological secrets, Mars, the red planet, may hold the keys to both our future and our past. If human beings ever inhabit another world in our solar system, this is the most likely candidate. The red planet, Mars. To a visitor from Earth, a tour of Mars might be very reminiscent of places back home. Places like Southern California's Mojave Desert, geo and astrobiologist Ken Nielsen finds this desert area so much like Mars, he comes here to try to better understand conditions on the red planet.
You travel around here in the dune buggy and you see features that look just like the dune features on Mars. If you go further and look in the background and see all of these red hills full of iron oxides that we see on Mars, Mars is filled with iron, and its oxidized iron basically rust, turns into dust particles. And in addition to the beautiful dunes, you have this red atmosphere, sometimes red all over the surface of the planet. Huge dust storms. They don't call it the red planet for nothing.
But while much of the Martian terrain is similar to Earth, some geological features dwarf any of their kind on our home planet. A mountain named Olympus Mons, Latin for Mount Olympus, is the tallest known peak in the solar system. It's a now dormant volcano that rises 15 miles above the Martian surface.
If you draw a picture of Olympus Mons and put it next to Mount Everest and the big island of Hawaii, even taken all the way down to the base of the ocean, they look like molehills compared with Olympus Mons on Mars. That mountain is so large, you could be on its slopes and you would not know that you're on the slope of a volcano because the base is so huge before you get to its summit.
Yet, as awe-inspiring as the Martian surface appears, it is a brutal, inhospitable zone for human beings.
6 green board, 5, 4, 3, 2, 1, engine start, and liftoff of the Delta II rocket carrying the Spirit from Earth to planet Mars.
It's cold, it's dry, it's desolate. There are dust storms that can darken the skies for weeks or even months at a time. It goes down to 100 degrees below zero at night, every night.
Compounding these cruel conditions is an atmosphere with no oxygen. Martian air and even occasional cloud formations are made up almost entirely of carbon dioxide.
So it's not a nice place. You wouldn't enjoy it if you went there.
Mars is small relative to the Earth, only about half the size of our planet. And its distance from us is never less than 34 million miles. it appears as nothing more than a tiny red orb in our night sky. Even so, Mars has captivated humankind for centuries. The planet takes its name from the Roman god of war. The Romans associated this distant world with hostility and unrest because of its blood-like color and because of its distinctive movement in the sky.
Mars wanders. It doesn't do what the stars do.
The red planet occasionally appears to be moving backward across the sky, a behavior that confounded observers for centuries. But in 1514, close study of this planetary movement led Polish astronomer Nicholas Copernicus to a revolutionary understanding of the solar system.
For much of recorded history, people thought that Earth was at the center of the universe. So along comes Copernicus, and he says, no, maybe the Earth isn't at the center of the universe. Maybe the explanation for all this is that things are going around the sun. And if all the planets are going around the sun, then we can explain why, as Earth passes Mars in the orbit, Mars begins to wander in our sky. It looks like it's going this way, and then it starts to go this way.
By the time of Copernicus's observations, Mars and the Earth had been passing each other in their respective orbits for some 4.5 billion years. Time enough for the two planets to have evolved into very different worlds. One warm, wet, and oxygen-rich. The other cold, dry, and oxygen-depleted. Yet it's now believed that the differences weren't always so stark. Scientists today think that Mars was once warm enough for large amounts of liquid water to flow across its surface.
When we look at Mars today in our best satellite images, they tell us the same message we heard with the first missions to Mars, and that is that there's no liquid water on the planet today. But there's virtually incontrovertible evidence that there was water there in the past. Everybody knows that when water flows through any sort of dirt, there are characteristic structures that are a function of that water running through. And when we look at the pictures of Mars, the satellite images, we see very similar structures leading us to the absolute conclusion that Mars was once far warmer and wetter than it is now.
Mars, of course, is a harsh desert today. So what could have happened? What cosmic processes could have brought about such a dramatic transformation of the fourth planet from the Sun? The story begins with the origin of the solar system. Somewhere in the range of 4.5 billion years ago, our solar system sprang from a supernova, a stellar explosion emitting a swirling mass of molecular particles and gases. This swirling mass, or nebula, began to cool, and as it did, it condensed and separated into rings of particles. These particles began to accrete, or gradually clump together to form planets. The accretion process creates heat, and heavier particles sink to the center of the accumulating mass. So Mars eventually formed a molten iron core. This churning molten core generated a powerful magnetic field. The field projected outward, surrounding Mars like a protective shield, blocking harmful emissions from the Sun.
You have this constant pressure from the sun, which we call the solar wind. The solar wind is made out of protons, electrons, cosmic rays, all of these kinds of charged particles that could ionize the atmosphere, as we call sputter it away.
But eventually, Mars lost its protective shield and most of its atmosphere. The moment the accretion process ended, the planet began to cool.
The iron core was no longer able to generate this magnetic field. And then the solar wind started pounding the surface of Mars. That's a scenario that a lot of people believe.
The loss of atmosphere stripped the Martian surface of warmth and pressure. And since water needs both warmth and pressure to remain in liquid form, water is no longer stable on the Martian surface.
You put a pan of water out on Mars, it's going to evaporate very fast and try to freeze at the same time. One or the other will win out, but you won't have a nice liquid pan of water.
That's not to say, however, that there is no water on the planet at all. While liquid water is no longer stable on Mars, frozen water, ice, is a different story. And evidence suggests that still today, tons of water ice might lie just below the Martian polar caps. Locked within that ice might just be the holy grail of space exploration. They are visible through simple telescopes on Earth. And they are unquestionably the first planetary features noticeable during an approach to Mars through space. The Martian polar caps, mysterious snowy white ice swirls sheathing the top and bottom of the red planet.
It's actually what we call dry ice, frozen carbon dioxide. The atmosphere is very thin and it's nearly all carbon dioxide. So when it gets very cold, what condenses out is carbon dioxide snow, carbon dioxide ice.
But while the white caps are certainly a colorful planetary feature, it's not the frozen concentrations of CO2 themselves that are of most interest to scientists. It's what's thought to be hidden beneath the polar caps that could have massive significance. Lurking just below the topsoil may be millions of tons of frozen water. Water ice, hidden from view, appears to radiate out hundreds of miles in all directions from the poles. And leading scientists think it could be the residue of once vast oceans.
Likely the water is now frozen in a kind of permafrost beneath the surface. But maybe there are pressures and temperatures in various areas of Mars that have liquefied the ice and created perhaps aquifers.
We can see craters, an impact has happened. Asteroid has hit Mars, blown out a lot of stuff. It doesn't blow out dry powder like on the moon and make rays and rubble. It throws out kind of a muddy slurry of stuff. So the conclusion is that you're actually impacting into ice like northern Canada, permafrost layers, tundra kind of stuff.
Orbiting spacecraft have picked up strong indicators for the existence of water ice at the Martian poles. Remote measurements of soil composition have detected high levels of hydrogen. Water, of course, is 1 part oxygen and 2 parts hydrogen, so the possibility of ice hiding below the surface in those areas is overwhelming. But while strong evidence of ice at the Martian poles may be relatively new, speculation that water existed there became common more than a century ago. And its implication that intelligent life could also exist on the red planet elicited widespread anxiety on Earth for much of the first half of the 20th century. Astronomers pointed the first telescopes toward Mars in 1610. As spyglass technology steadily improved, the blurred image of the red planet drew ever closer to the eyes of earthly observers. By 1877, telescopes could enlarge the image of the distant planet so that it appeared roughly the size of a dime held at arm's length. Certainly not impressive by modern standards, but it was enough for the director of the Milan Observatory, Giovanni Schiaparelli, to attempt to sketch the Martian surface and name its geological features. Schiaparelli peered at the hazy, shifting visage night after night for months.
And he sees what he thinks are crisscross lines on the surface of Mars. Turns out later, what he saw isn't exactly what's up there, but still through his crude telescope, that's what he could see.
The respected Italian astronomer sketched these lines and gave them a name.
Schiaparelli interpreted these lines as channels of some sort. He didn't really know. Well, the Italian word that he applied to them was canali. That word, translated to English, should have been translated as channels, but instead it got mistranslated as canals.
Since straight lines do not normally appear in nature, Schiaparelli's sketches gave birth to the idea that some form of intelligent life must exist on Mars. It was an arresting notion, widely debated among astronomers of the day. Later, in 1894, a wealthy Bostonian named Percival Lowell was so intrigued by this possibility that he paid to have a large telescope constructed on a mountainside in Flagstaff, Arizona. He spent the next 2 decades observing, sketching, and speculating about the red planet.
He convinced himself that he was seeing networks of straight lines on Mars, which he thought were canals. What was the big news of the day? The Panama Canal. That's what great planetary civilizations do. They build canals. So this was canals to bring the water down from the polar ice caps. Mars was cold and far from the sun and dry, and so he knew that, and so he thought, well, I have to move the water to live on Mars. Well, that idea just electrified everybody, that there was a civilization on Mars.
Against this backdrop, on Halloween night 1938, a young actor named Orson Welles broadcasted a dramatization of War of the Worlds, a novella by British author H.G. Wells, in which sinister Martians land on Earth and wreak havoc.
We now return you to Carl Phillips at Grover's Mill.
Ladies and gentlemen, here I am. Wait a minute, something's happening. There's a jet of flame springing from the mirror and it leaps right at the advancing men. Lord, they're turning into flames.
Thousands of citizens believed the invasion was real.
We're deeply shocked and deeply regretful.
The misunderstanding was short-lived, but even so, the broadcast only served to fuel public speculation about potential intelligent life on Mars. Mars, it had intrigued humankind for thousands of years. And in the mid-20th century, humans finally got a closer look at the mysterious planet. In 1964, the National Aeronautics and Space Administration, NASA, launched a small exploration spacecraft toward the red planet. Its name was Mariner 4. It had a television camera, and its mission was to fly past Mars and send back pictures. It could only make one pass. Scientists were filled with anxious excitement at the prospect of what they might see.
Is it going to see cities? Is it going to see canals? Is it going to see forests? Well, what it saw was craters. It sent back pictures which just were very fuzzy and showed craters like on the moon.
It was a huge letdown. The Mariner 4 images revealed a dry, cratered, desert-like, and seemingly dead planet.
Sort of like the moon with a little air to blow the dust around.
But the enthusiasm for exploring Mars was only tempered. And 6 years later, in 1971, NASA sent another spacecraft to the red planet, Mariner 9. But this time, rather than just making a single pass by Mars, Mariner 9 was engineered to orbit the planet for weeks and do a complete mapping. The effort paid off. After waiting out a planet-wide dust storm, Mariner 9 started returning spectacular images. It discovered the Tharsis Bulge, the sort of potbelly of the planet near the equator. The bulge is a result of concentrated and massive volcanic activity. The dominant feature of the Tharsis Bulge is the monster volcano Olympus Mons.
Olympus Mons is about the size of Missouri. If you put it in the middle of the U.S., it would dominate that picture. If it had a major eruption, a volcano of that size would probably fill up one state on every side of Missouri, so my hometown in Iowa would be under lava. Interestingly, it's composed of, we think, 3 separate volcanoes, or at least it's erupted in 3 different ways. If you fly over the top, you see 3 separate calderas. So it isn't just 3 times larger. This is a monster geological event. But in fact, if you were on the edge, the slope is so gradual and the peak is more than 100 miles away that you wouldn't know that it was a volcano. It's that massive.
And Olympus Mons is not alone. A few hundred miles southeast of the mountain stands a diagonal row of 3 other evenly spaced enormous volcanoes, each larger than any of its type on Earth. Yet, as magnificent as it is, the Tharsis region isn't the only spectacular geological feature discovered by Mariner 9. At the eastern edge of the bulge is a colossal tear in the crust of the red planet. It's called Valles Marineris, Mariner Valley, in honor of the Mariner 9 orbiter itself.
You look at this thing, it is like the width of the United States. It's this cleaved valley. You know, the Grand Canyon in the United States? Pump it up, put it on steroids, make it the size of the United States itself, you got Mariner Valley.
The geological mechanism that caused this immense rupture in the Martian surface is yet a mystery. Scientists can only speculate.
One mechanism which I like is that there's a place called the Tharsis Bulge not far away, in which so much lava and other things have accumulated that it's felt it could put a giant torque on the surface of Mars and pull this apart like a zipper. Well, who knows if that's true, but one needs a mechanism different from anything that we know to explain the existence of that.
With the stunning success of Mariner 9, the next logical step for NASA was to land a spacecraft on the actual surface of Mars. Scientists were eager to test rock and soil samples for signs of life. In 1976, the Viking mission reached the planet to do just that. It had both an orbiter and a landing component, equipped with robotic test instruments.
and we get right down on the surface and we scoop up some soil and we don't find a thing. Mars looks like a cold, dry, dead place.
But while the Viking lander toiled away on the ground, failing to make headlines, high above the Martian surface, the Viking orbiter managed to capture a mystifying image. While flying over a region of Mars called Cydonia, the orbiter snapped an image of a land formation under cross-lighting. Startlingly, the formation resembled a human face. As a joke, NASA scientists showed the photo to the press, remarking about the face they'd found on Mars. Under more even lighting conditions, of course, the Martian terrain feature does not look like a face at all, just a jumble of hills. But in certain circles, the story of the face on Mars and its NASA cover-up persisted for several years. True Mars enthusiasts, on the other hand, faced a more sober reality following the Viking mission. With no definitive evidence of biology resulting from the Viking experiments, interest in returning to the Red Planet quieted for several years. Then, in 1984, a young scientist on an expedition in Antarctica made a discovery that ultimately infused new energy and hope into the quest to uncover life on Mars. In December 1984, NASA geologists on a meteorite gathering expedition in Antarctica found an odd specimen. A meteorite with an unusual color, a sort of green hue. Most are gray or brown. Back at NASA's Johnson Space Center in Houston, where such rocks are stored, it was labeled ALH 84001. Despite its odd color, the scientists assumed that it was a piece of an asteroid.
So the rock was pigeonholed into a group of meteorites, and it stayed there for 6 or 8 years. Misclassified.
Then, in the early 1990s, an analyst researching asteroids placed a piece of ALH 84001 under an electron microscope. He soon realized he was not looking at a normal meteorite. He was looking at a piece of Mars. The rock had characteristics that matched another Martian meteorite found in 1979. More scientists began studying this sample, and they were astonished when they eventually found what looked like carbon globules. Carbon, at least on Earth, is the primary building block of life. Senior scientist David McKay headed up the research group.
My imagination was ignited by the carbonates. And I said, hey, these carbonates are really strange looking. How do they form? Let's look at those.
Closer scrutiny of the rock sample brought even more startling discoveries.
The kind of chemistry that went on in those globules is associated with life on Earth.
At least one scanning electron microscope image revealed a structure that looked suspiciously organic, almost like a worm. Could it be a trace of primitive Martian biology?
I think that worm is biologic. Whether it's a complete fossil of bacterium is problematical. It could be a part of a bacterium. It could be a section of one, but it's biologic in my view.
I'd like to welcome everybody here today. It's an unbelievable day. It's very, very exciting for me.
Finally, in 1996, after more than 2 years of study in which they had built 4 independent lines of evidence, the team was ready. they announced their hypothesis. ALH 84001 contained possible evidence of past life on Mars.
We conclude that this is evidence for early life on Mars.
NASA held a major press conference, but not everyone was convinced. Labs across the globe requested samples of the rock to conduct their own analyses. In the end, after months of, at times, acrimonious debate, the consensus was that there was no consensus. Papers were published in support of the claim, but many more were published debunking the idea.
If I could have the first slide, please. The features that you see may be any number of things. For example, they could...
Many researchers are convinced that the formations in the rock that appear to be signs of Martian life were actually caused by mineral activity.
The majority of people would say that there is no relic biogenic activity in this meteorite from Mars. Dave's initial hypothesis was incorrect. I would say at this point that that's too simple a hypothesis to take. I don't think the work has been completed to a satisfactory endpoint to say either way.
Work on the meteorite is continuing. But even if researchers never confirm that the rock contains signs of Martian life, the ALH 84001 episode has already completely reinvigorated interest in the quest for life on the red planet. Ironically, the new push to find life on Mars has often led scientists yet again to the continent of Antarctica. Conditions in this part of the world are analogous in many ways to conditions on Mars. Seeking out life forms that manage to thrive in extreme circumstances here might shed light on how and where primitive life could have once taken hold on the red planet. One environment astrobiologist Dale Anderson focuses on is at the bottom of lakes, covered year-round with thick layers of ice.
Most people said that because of the thick ice covers, you would find nothing but rocks. There would be very little to nothing on the bottom.
The ice layer sealing off many of these lakes is up to 15 feet thick, but rather than trying to blast or drill through it and disturbing the ecosystem below, Anderson and team have found a much less damaging approach. They let a massive coil of copper tubing make an opening.
Then you just pass a hot liquid through it, throw it out on the ice, and let it melt its way down. It takes about 24 hours. It melts through the ice, then we put this very nice, clean hole to dive through.
Divers enter the water wearing full-body dry suits. And what they find at the bottom of nearly every Antarctica lakebed is a testament to the stubborn tenacity of life. Mats of microbial organisms are thriving in frigid environments that receive virtually no sunlight.
Most people thought that if you had less than about 1% of the surface light, you wouldn't have any photosynthesis taking place down on the bottom. They wouldn't be able to use enough light to live. It's turned out that they can photosynthesize with light levels down to 1/10 of 1%.
For Anderson and his team, the pristine mats are truly a window to the past.
There are no higher organisms, no fish, no insects, no animals creeping through it. So these microbial communities have the opportunity to grow by themselves without interference from other animals or plants. And that gives them the opportunity to grow in very special ways.
Is it possible that a similar form of microbial life could still reside somewhere beneath the frozen surface of Mars? Especially at the hydrogen-rich poles? Anderson and scientists like him believe it is worth investigating.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, engine ignition, and liftoff of the Delta II rocket with the Mars Exploration Rover.
In the summer of 2003, NASA's Jet Propulsion Laboratory delivered 2 exploration spacecraft to the surface of Mars. Missions to the Red Planet are only feasible once every 2 years during a specific short window of time. The launch must be timed so that the spacecraft and Mars arrive at a specific point in the planet's orbit at the same time. The journey across the 34 million mile distance can take up to 7 months, and the trajectory must be perfect.
The accuracy required to go from Earth to Mars and to hit the spot you want to be at on Mars is equivalent to shooting a basketball from Los Angeles to New York and have it go through without hitting the rim, nothing but net.
All systems are go for entry, descent, and landing. We are currently 6 minutes from landing at the Gusev crater in the southern hemisphere of Mars. Current velocity 1,356 miles per hour. Expected parachute deploy in 5 seconds. Parachute lift detected. Expected retro rocket ignition on my mark.
The spacecraft were actually rovers, robotic vehicles capable of traveling across the Martian surface and poking around.
The rovers are robot geologists. Their job is to be our eyes, our feet, our hands on the Martian surface. We experience Mars through them. They can reach out and they can touch rocks. There's this device called the RAT, R-A-T, the rock abrasion tool, which is a diamond tip grinding tool that we can use to grind into the interior of a rock, and so we can actually get a window inside the rock. They have sensors on the end of that arm, like there's a microscope for telling us in detail what they look like. So we've got a whole bunch of tools similar to what a geologist would want if they were actually physically there on the scene.
The rovers were named Spirit and Opportunity, and they are still exploring regions of Mars today at locations on the planet hundreds of miles from each other. Spirit landed in an area dubbed Gusev Crater. The crater is believed to be a dried-up lake bed, so if the water it once held contained biology, Spirit might uncover signs of it. Opportunity touched down in a region called Meridiani Planum. The area is intriguing because it contains an ancient layer of hematite, an iron oxide that on Earth usually forms in a spot that held liquid water. So far, neither rover has found signs of life. But both Spirit and Opportunity have uncovered ample proof that liquid water was once plentiful on the surface of the Red Planet.
We've seen places where water soaked the rocks beneath the surface. We've seen places where water came to the surface and flowed over the Martian surface, creating little ripples that are still preserved in the rocks billions of years later.
But neither rover is close enough to the tundra-like Martian poles to uncover actual frozen H2O. That is the primary goal of a new mission to Mars, launched in the summer of 2007. This mission is dubbed Phoenix, and its plan is to place a stationary lander in the region of the Martian North Pole. The lander has a sturdy robotic arm equipped with a scoop. Phoenix will excavate the polar soil. Dr. Peter Smith of the University of Arizona heads up the project.
Our entire scientific mission is about understanding the properties of the soil and its interaction with the ice, and the properties of the ice and the ice interaction with the atmosphere. We have only one way to study it, and that's by using our robotic arm as our backhoe, if you like, that's going to dig a little trench and provide samples of both soil and hopefully wet soil, if we can find it, and ice. And we will analyze those samples with instruments on the deck of our spacecraft.
The lander will beam signals back from the Martian surface, reporting the results of the remote soil and ice analyses. But before Phoenix has even had a chance to make it off the launch pad, a new wrinkle in the saga of water on Mars has revealed itself. Images beamed back from a spacecraft currently orbiting the red planet show evidence of a very unexpected event. It appears that a liquid flow of some sort has occurred within the last few years in a small gully at the edge of a deep Martian ravine. In 2001, the orbiter took photos of the exact same spot, but nothing of interest showed up in those shots. The new photos, on the other hand, showed a white residue in the gully, a residue seemingly left behind by a flow of liquid, possibly where water spurted from the ground and flowed for several hundred yards before transforming into vapor and vanishing. Scientists do not yet understand what might have caused such a flow, but many suspect that it's a result of some form of internal heat the planet must still contain.
Clearly, it's a planet that's been volcanically active. And all of us are very hopeful that some places on Mars we could find hydrothermal vents. And not just because we want liquid water, but because the liquid water implies that this might be an environment that life could develop or be maintained.
It is, of course, all about the search for life. When all is said and done, the engine driving all of the astonishing scientific effort to explore the red planet is the burning desire of humankind to know if life exists elsewhere in the vast reaches of space.
I think humans have, since the dawn of consciousness, wondered why they're here, and wondered what's up there, and wondered if there's more. And answering that question will sort of put us in some kind of perspective. It'll tell us what our place is in the universe to some extent.
Finding life on Mars could also help us understand the origins of life on our own planet.
And there could actually be, in the case of Mars and Earth, a significant connection. You know, if Mars developed life itself, maybe the conditions were right on Mars, but they weren't right on Earth. But yet Mars seeded our planet. Perhaps through meteoritic collisions, pieces of Mars arrived on Earth. With cells of life, and that actually grew here. Maybe we could all be Martians. Or perhaps it was the reverse, you know, perhaps life originated on this planet and moved to Mars.
If we find evidence for life on Mars, and we know there's life on Earth, of course, then there's probably life all over the place. The universe is probably teeming with life. And if it didn't, then it makes us feel, I think, a little bit more special.
Earth, the only life-sustaining planet in our solar system. Yet throughout its history, our world has been a planetary punching bag.
Anything that crosses the orbit of Earth could one day slam into the Earth.
At this very moment, violent celestial heavyweights roam the universe and threaten to deal the Earth a knockout blow.
The power would be like setting off the whole world's armament at one time. It would be like standing next to Hiroshima all over the world.
Everything in us would get ripped apart, and your body would fly off to infinity.
But some scientists and former astronauts are not willing to go down without a fight. They're racing to track down these cosmic killers before they trigger Armageddon. Earth shimmers like a sapphire jewel in our solar system. We go about our days unaware that in the far reaches of space, trouble could be headed our way.
Our solar system is a lot like an amusement park. Earth and most of the other objects carve predictable paths around the sun. Normally, everything is calm and smooth. But at times, things get chaotic and violent. Earth can be slammed by space rocks, zapped by deadly space weather, jolted, jostled, and threatened by the object's energy and forces of the cosmos.
The Earth is on a cosmic thrill ride, one that often involves extreme danger.
When you're moving fast and on a predetermined path, you hope nothing crosses it because there's nothing you can do.
Nicaraguan border goes right down along.
Former astronaut Rusty Schweickart knows firsthand how dangerous celestial objects can be. In 1969, he piloted the lunar module during the Apollo 9 mission. Now, Schweickart is ready for more than a cruise through the cosmos. He's sounding alarms about the dangers of one particular asteroid named Apophis, which got too close for comfort in 2004.
It immediately got everybody's attention because the probability of impact was quite high. In fact, it was higher than any impact probability that we had ever seen up until that time.
And Schweickart has a terrifying real-life example of just how damaging an impact from an asteroid even smaller than Apophis could be. June 30th, 1908, 7:15 a.m. An object half the size of a football field plunged down from space at around 34,000 miles per hour and produced a stream of fiery gas behind it. Within minutes, the fireball entered our atmosphere and violently exploded above Siberia's Tunguska forest. It became the largest explosion on Earth in modern human history. The blast sparked heat waves, which torched 80 million trees in an area over half the size of Rhode Island. Fortunately, no one died as a direct result of the explosion, because it was in a thinly populated area.
If that asteroid hit just a few hours later, it would not have hit Siberia, it would have hit over Europe. And if that had exploded midair over any of the major cities of Europe, 1 million people would have died like that.
For the last 100 years, the Tunguska explosion has been shrouded in controversy. Today, many scientists agree an asteroid caused the blast. Incredibly, it never even impacted the ground. Rather, it exploded 5 miles above Siberia's frozen ground.
A small, stony asteroid can't survive the plunge through Earth's atmosphere. When it smacks into the lower atmosphere, doing about 50,000 miles an hour, it's like an egg smashing onto concrete.
The blast over Siberia released energy equivalent to 15 megatons of TNT, 1,000 times greater than Hiroshima. If this were to happen over a large city, it would annihilate it. Scientists call these trespassers near-Earth objects, or NEOs. They're asteroids and comets, which are leftovers from the formation of the planets. Comets move in the Oort cloud and the Kuiper belt, which is beyond the planet Neptune. Asteroids travel in a band between Jupiter and Mars, but their orbital trip isn't always routine.
Most of the asteroids orbit in a neat belt between Mars and Jupiter, and we don't worry much about those. But when one gets away and all that mass and energy is headed towards Earth, that's when the astronomers start to worry.
Oftentimes, these cosmic remnants get bumped out of their orbit and head on a collision course with Earth. Our planet's thick atmosphere vaporizes the vast majority of them. But a larger object can knock through our atmosphere and actually impact the ground.
If you want to turn to the cosmos and look at the forces that would have us dead, asteroids striking are real and they're bad. It's happened before, it will happen again.
65 million years ago, an asteroid the size of a small city plummeted down from the sky. It exploded in the Yucatan Peninsula near the present-day Mexican village of Chicxulub with the force of 100 million megatons of TNT.
It hits the Earth, casts billions of tons of Earth's crust into the atmosphere, cloaking Earth, blocking out sunlight, knocking out the base of the food chain, and sending a wave of extinction across the tree of life.
It is believed the ferocious impact contributed to the mass extinction of the dinosaur.
We can think of asteroids as being bad things, but were it not for an asteroid, we wouldn't be here today. Our mammal ancestors were running underfoot, trying to avoid being hors d'oeuvres for T-Rex. T-Rex gets taken out. Well, this opened up an ecological niche that allowed our mammal ancestors to evolve to something more ambitious than a rodent. And out comes the primates, and among the primates we have people.
But ironically, the very kind of cosmic boulder that paved the way for humans to exist may one day wipe us off the planet. In 1998, Congress urged NASA to detect all the near-Earth objects over a half-mile in diameter or more. And what they found was unsettling. Over 850 NEOs in our vicinity. These asteroids are our closest and most dangerous neighbors in the solar system. Donald Yeomans heads the NEO program at NASA's Jet Propulsion Laboratory. He and his cosmic bounty hunters search for potential killers lurking in our solar system and put them on their most wanted list.
Finding these near-Earth objects is somewhat akin to tracking hurricanes. As you track it day after day, you get a better idea of its orbit. You can predict where it's going. You have a better idea of how large it is and if it should hit the Earth, with what sort of velocity.
By using telescopic technologies, NASA's Space Guard survey has detected over 90% of all NEOs deemed harmful. These frightening objects could strike the Earth with the energy greater than all the nuclear weapons on our planet today. Such an impact could trigger mass extinction.
You wouldn't expect one to hit but every several 100,000 or millions of years, but if one did hit, it could wipe out a fair fraction of the population. So they're very low probability events, but high consequence events.
If they hit the Earth, they would have global effects. I mean, not only would you wipe out a continent with really heavy shock waves, but the ejecta would be thrown up in the air and come down all around the planet. The atmosphere itself would get to 1,000 degrees or so, and all the vegetation all over the world where that happened would flash into flames.
Cataclysms could also occur with smaller objects. So Congress now asks NASA to locate all NEOs 500 feet in diameter, as wide as the Roman Colosseum. An object that big could decimate a metropolitan area or even a small state. And what worries scientists most is not the asteroids they've discovered, but the ones they have not yet found.
At any given time, there's about 24 objects for which we can't yet rule out an Earth impact.
Former astronaut Schweikert has taken the threat of NEOs one step further. He's appeared before Congress to request a special government agency be responsible for protecting the public from space rocks.
Today, we have the technology to stop near-Earth objects from impacting the Earth for the rest of history. I mean, we can literally now begin to reshape the local solar system so that our survival is enhanced. The question is, will we? Or will we go the way of the dinosaurs?
But Schweikert isn't waiting for NASA or Congress to solve the problem. He has his own plans to save the planet from the next asteroid impact. It's hard to believe the Earth has survived over 4.5 billion years, because since its infancy, the planet has taken a beating. Like a boxer, our world is under constant assault from asteroids that enter our orbit each year. But in the future, Earth could be knocked out. Former Apollo 9 astronaut Rusty Schweikert refuses to be bullied by asteroids. And now he's ready to defend Earth against these harmful rocks.
We've discovered that there are these near-Earth objects flying by us all the time. And we've gotten more and more capability to modify our environment to enhance our survival.
Schweikert is particularly concerned about an asteroid named 2004 MN4, better known as Apophis. This pockmarked rock, approximately 750 feet in diameter, swept near Earth in 2004. Now it's scheduled to pass dangerously close to our planet again on Friday the 13th in April 2029.
So in 2029, Apophis will come closer to us than our own communication satellites orbiting the Earth. It will be so close that people who are in the right place will be able to see Apophis go by the Earth with your naked eye. You won't even have to have binoculars. That's how close that asteroid is going to come.
Apophis has an over 99% chance of missing the Earth in 2029. But if Apophis passes the Earth at a distance of exactly 18,893 miles, it may pass through a gravitational keyhole, a narrow region in space a half-mile wide. If this happens, the Earth's gravity could upset Apophis and change its trajectory. It could cause it to return and hit Earth 7 years later, on April 13th, 2036.
The gravitational effect of the Earth will cause it to bend, cause the Apophis orbit to enlarge to precisely the size which 7 years later it will come around and hit the Earth.
At the present time, Apophis has a 1 in 45,000 chance of delivering a deadly blow in 2036. But even these odds have scientists placing bets.
It's one thing to know that there's maybe 1 chance in 45,000 that it's going to hit the Earth, but what you'd like to know, is there 1 chance in 100? Is there 1 chance in 10? Is the probability 1 that it's going to hit the Earth?
Schweikert believes we must regard Apophis as we would any natural disaster. He's even mapped out where Apophis might strike.
You have the date of the impact, the time of the impact, the orbital inclination, and you can make a map. And what that map shows is what I have called a path of risk that goes all the way across the planet. And I look at this and I see a high probability of impact and I say, whoa, you know, where might it hit?
According to Schweikert, Apophis could impact any point along this path of risk. It begins in western Siberia, cuts across and down the Pacific Ocean near California. Then it traverses Central America and finishes in Western Africa. Schweikert proposes a chilling scenario of where Apophis might strike. The asteroid could land in the Pacific Ocean off the coast of California with the force of over 1 million megatons of TNT. Such an impact would create a 5-mile wide, 9,000-foot deep crater in the water, which would unleash tsunamis. Relentless 50-foot waves would pound the coastline, resulting in unimaginable human loss.
An asteroid that's 1,000 feet in diameter, having it hit in the ocean is not a good deal. Hundreds of billions of dollars of damage from something like that.
Scientists are presently working on technologies to preempt such a cosmic strike. One idea involves blowing up an asteroid. But some feel this could compound the problem, sending several chunks of the asteroid in our direction instead of just one. Consequently, Schweikert's new mission is to change the orbit of asteroids that could impact Earth.
What you want to do is basically change the asteroid's orbit very, very slightly. You change its velocity by a 10,000th of a mile per hour so that it will miss the Earth instead of hitting it.
Rusty's colleagues have drafted conceptual designs of spacecraft that could deflect asteroids, particularly Apophis. One would tow harmful asteroids away from Earth. But instead of lassoing the rock like a bull in a rodeo, the tractor will hover in front of it and use gravity as a tow line.
If you park in front of an asteroid for a long enough period of time and you stay close enough to it but not touching it, you're going to increase its velocity. Or if you park behind it while it's moving along, you're going to slow it down very slightly. We can change the orbit of an asteroid if we know about it far enough ahead of time.
Although a space probe has landed on an asteroid in the past, the most challenging idea is launching a manned mission. Once landing on the rock, astronauts could mount a radio transponder to track its whereabouts.
You could just use a robotic mission to go to an asteroid, land, grab a sample, and bring it back. That's not that difficult. What you gain by a manned mission is they can react to interesting areas on the asteroid surface. They could go here, there, and they wouldn't have to rely on remote navigation.
Nicaraguan border.
Schweikert insists we should remain on high alert regarding asteroid Apophis, and his cause hasn't gone unheard. Now the United Nations plans to draft a treaty which will include who will be responsible for deflecting killer asteroids.
That would be a real crime if we are so irresponsible, knowing that this is going to happen, that we continue to do nothing about it.
But asteroids and comets are not the only deep space threats.
Earth has had its ups, and Earth has had its downs. We never know what's going to be around the next corner, and a lot of it is bad.
In far-off galaxies, galactic invaders are at work, itching to end life on the planet as we know it. 3 times daily, a strange flash pulsates across our sky. It's hundreds of times more powerful than the world's total nuclear armament, but it's not man-made. And if one happens close enough to Earth, it could end life on our planet. Most Earthlings are unaware of the potential hazards in space, but the list is long and growing. Imagine this. Within our own galaxy, the Milky Way, a massive star explodes, sending a lethal burst of energy rocketing toward our planet. This is a gamma-ray burst, the biggest explosion to rock the universe since the Big Bang. In the cities and countryside below, there's no warning of what's about to happen. And then it strikes.
It would be equivalent to standing 1 mile away from Hiroshima, any place on the Earth.
The potent radiation cooks the upper atmosphere. Our ozone layer roasts. Across the hemisphere, human beings burn to death from radiation 100 times the fatal dose. The disappearing ozone layer causes increased temperatures around the world, triggering cyclones, tsunamis, and hurricanes. Most life on the surfaces of land and water incinerates. This may seem like science fiction, but it could happen if a gamma-ray burst hit Earth from 100 light years away.
Gamma-ray bursts are the brightest explosions in the universe. Because they're so far away and yet still so brilliant, they must involve an enormous amount of power. As much energy as the sun will emit in its entire 10 billion year lifetime.
As a young student, Stan Woosley always liked experiments that go boom. Now, the work of this astrophysicist is more than child's play. He's one of the galactic detectives trying to uncover the mysteries behind gamma-ray bursts.
We know there are many planets and many stars throughout the cosmos, so there may have been countless civilizations that were destroyed by gamma-ray bursts.
These peculiar beams of radiation were first spotted in the 1960s. At first, most astronomers believed these gamma-ray bursts must exist in our own galaxy, the Milky Way, because they're so bright.
There were reasons for that. One was that if they were outside the galaxy, the energy was almost unbelievable.
But at the time, even the most powerful telescopes couldn't determine their location and distance, because the bursts lasted for a few seconds, then disappeared. But then astronomers wondered, what about their afterglow? Cosmic explosions typically leave behind some luminous residue that sometimes lasts for days or weeks. In the late 1990s, satellites used upgraded optics and X-ray detectors to finally capture a gamma-ray burst's afterglow.
It became clear that gamma-ray bursts actually were cosmological, coming from very far outside of our galaxy, from millions and billions of light years away. And that meant their energy had to truly be astronomical.
To get some idea of how incredibly bright a gamma-ray burst is, we could represent the brightness of our sun by this relatively dim LED, and we could represent the brightness of the gamma-ray burst by the very, very intense searchlight that's behind me. Isn't that incredibly bright? Unfortunately, with this comparison, the searchlight is not nearly bright enough to represent fully the gamma-ray burst, and in fact, we would need 100 billion such searchlights to have an adequate comparison. The gamma-ray burst is equivalent to the brightness of 1,000,000 trillion suns.
These massive bursts could decimate Earth. But what causes them?
We are quite convinced that the common gamma ray burst comes from the death of a massive star, at least 10 times the mass of the Sun. And such stars are quite rare, by the way.
Woolsey masterminded a groundbreaking model of how gamma ray bursts may be created. When an extremely massive star dies, it collapses into a black hole. Black holes are created when a collection of matter collapses to such a high density that light itself cannot escape. But Woolsey proposes that some of the star resists getting sucked into the center of the black hole. As a result, a high-speed spinning disk of matter forms around it. Within seconds, jets of plasma shoot out from its rotational poles. These beams of energy unleash dangerous gamma rays into space.
If you can imagine just trying to squeeze a fruit or some kind of sphere of some object into a very small space, things are going to squirt out. And in this case, the squeezing is done very rapidly, and you're talking about a huge amount of mass.
At the same time the gamma ray bursts are ejected, the collapsing star explodes or goes supernova to the extreme.
One of the reasons gamma ray bursts are so incredibly bright is that they take an enormous amount of power and then they focus that power into a very small portion of the sky. For every 300 gamma ray bursts that go off, only one is pointed in our direction, and so we only see one of those 300.
Even if a gamma ray burst were to occur not 100 but 1,000 light years away, the Earth could still face apocalyptic destruction.
If a gamma ray burst happened within 1,000 light years of the Earth, then it would be approximately 500 times brighter than the Sun and emitting gamma rays. The energy delivered to the Earth's upper atmosphere would be like 100,000 megatons of nuclear explosions. The ozone would be depleted. We'd have acid rain, but we'd also have flash burns, incineration of vegetation, perhaps something resembling nuclear winter. So there could be a global extinction of many species. Now, the far side of the Earth would be a special place to be, because gamma rays don't go through the Earth, and if you were on the other side, you wouldn't get flash burned. But the effects of depleting the ozone and changing the composition of the atmosphere would eventually come to the other side, and there the effects are unknown.
Statistically, this ghastly scenario has a 1% chance of happening once in the Earth's entire lifetime. But even these odds aren't reassuring if you're living on the planet at that very moment.
If you're caught in the beam, that's a bad day for you. If one of these happens in your galaxy and that beam is coming your way, go hide in a cave, because this is very high energy radiation. It's the kind of energy that will decompose your molecules, and you just don't want to be around when that's happening.
There currently are no defense measures to shield us from gamma ray bursts if they happen close to Earth. They travel at the speed of light, 186,000 miles per second. By the time we detect them, they will have already struck our planet.
Gamma ray bursts could pose a hazard to the Earth or to anything living that came within their bore site, but as we've seen, they're very infrequent. And there are other things in the heavens and on the Earth that are much more dangerous.
Cataclysms routinely erupt in some corner of the universe. And one day, something will snuff out Earth.
Most of the time, our ride around the sun is gentle and uneventful like this Ferris wheel. And as long as nothing gets in our way, we could go on like this for millions of years. But sooner or later, we know that this smooth ride will come to an end. We just don't know when.
Sadly, our planet's ultimate demise will probably come from the very thing that provides us life. Earth maintains a cozy lifestyle, being third rock from the sun. For over 4 billion years, the sun has been an ally, warming and feeding our planet. But in time, our solar heater will become our enemy.
The sun and the Earth have a unique relationship to each other. The Earth has a particular temperature, it's a particular size, it has life on it, and oceans, and those things depend on the sun. The sun is at the root of the existence of life on the Earth, and the sun will be at the root of its demise as well.
Earth's relationship with the sun will become dysfunctional when our solar mother really turns up the heat.
The sun gets hotter because it's burning hydrogen into helium. 4 hydrogen atoms become 1 helium atom. That means there are fewer particles bouncing around inside the sun. And that process basically means that the sun has to get hotter and brighter to hold itself up.
As the sun's core gets hotter, its outer parts will swell in size and turn red.
If you have a bonfire, you have all this wood there, you build it up, and at some point enough logs get burnt and the thing collapses and you get this huge burst of sparks and it gets much brighter. In a sense, it's like that because the sun is right now burning hydrogen into helium, and the helium is the ash of that, if you like. And then as the sun collapses enough, the ash relights and the helium burns into carbon. And that's when things get really hot.
At this point, the sun will expand into a red giant and incinerate most complex life on Earth.
When the sun becomes a red giant, it will grow to 30 times its size. So the surface of the sun will actually be out beyond the orbit of Mercury. The luminosity of the sun will go up by like 1,000 times. And that's going to make the Earth so hot that the outer crust, the rocks, the solid part of the Earth, will melt. The whole planet would be a glowing ball of lava.
The sun will fry the inner planets, and even though the sun will become red and cooler, the Earth will be much hotter. Just leave the Earth a burnt cinder, like a charcoal briquette. So that would be bad for life on Earth.
And the Earth's hellish fate isn't over. As a red giant, the sun will fluctuate in size before collapsing into a white dwarf.
The sun that was huge suddenly becomes the sun that's very small and extremely dense. It's only about the size of the Earth, sitting down there at the center of our solar system, very much fainter than it used to be, and then everything cools off. And then that object is no longer generating energy either, so it begins to cool as well. So the final fate of the solar system will be to cool off and freeze.
Humans will probably have relocated to another planet or become extinct before the sun turns Earth into a snowball. However, the sun may dry up our world much sooner.
If the sun doesn't get us at the time of the red giant phase, it may well get us earlier by just becoming bright enough to cause the oceans to evaporate. Water is an essential component for all life. And so if the Earth actually loses all its water, then that's another reason why life might disappear from the Earth, and it would again be the sun's fault.
There may be ways for Earth to win a stay of execution.
As the sun is swelling, it also begins to lose mass much more rapidly than it's losing it now. And of course, if it's getting less massive, it has less of a hold on the Earth will move further out into a larger orbit. And so it's kind of a race between the growing sun and the growing heat from the sun and the Earth actually moving, a little bit away from that fire that's getting too hot.
If our planet somehow manages to avoid getting fried or frozen by the sun, its future remains increasingly bleak.
This place is full of adventure. Rides that put your stomach up into your throat, things that collide, scary stuff. It's a lot like riding around the sun on planet Earth. But when Earth gets smacked or when things start to come apart, the ride could really be over.
I don't know what that means for the universe to end, because I like time. I live in it. So it's hard to imagine time ending.
Today, scientists contemplate our inevitable fate. In the distant future, the Earth and the entire universe may face the ultimate cosmic monster. No one suspects that Earth's most lethal enemy lurks amongst the stars. But in the future, and without prior warning, a cosmic Grim Reaper will unleash the ultimate Armageddon. The dark villain will stretch apart the universe. Galaxies themselves will split apart. Stars and planets will tear to shreds. The ultimate apocalyptic event is being called the Big Rip. And when it begins, it won't stop until every atom and nuclei in the universe are mincemeat.
The Big Rip, it really is the end of the universe. It's not like we're the last ones at the party wondering what's going on and we can go do something else. It's really like you've turned off all the lights and the universe just ends.
Innovative physicists Robert Caldwell and Mark Kamienowski proposed the notion of the Big Rip, a grim hypothesis about the final fate of the universe.
We used to think that the universe, which is currently expanding, could reach a point of maximum expansion. The Big Rip is the idea that the expansion will not only continue and accelerate, but rip everything apart as it does so.
Caldwell and Kamienowski calculated that the universe is expanding at an alarming and increasing pace, and that something is sucking everything outward like a vacuum. Acting like a galactic vice squad, these young scientists hunt for the cosmic killer. They believe a mysterious phenomenon called dark energy may be the culprit.
Figuring out what dark energy is probably the #1 goal of cosmologists today. Dark energy is dark, so you can't see it. We can feel what it is. We feel it through its effects on the gravitational behavior of the universe. There could be some dark energy in this room, under the chair. It's only when you look at its properties on really big cosmological length scales, billions of light years across, that you start to see the cumulative effects of the dark energy. It causes things to be pushed farther away from each other and contributes to the expansion of the universe in a quickening pace.
Edwin Hubble, whom the Hubble telescope is named after, first discovered the universe is expanding back in the 1920s. But it wasn't until 1998 when a crack team of scientists measured that this expansion is moving like a runaway train.
A nice analogy is to imagine that the universe, our three-dimensional space, is like the surface of a rubber balloon that I'm blowing up. Okay, I'm going to blow up the balloon as a demonstration of the effects of the expansion of the universe. As the balloon gets bigger, that's the depiction of the expansion of galaxies.
There's a galaxy, another one.
Where's our galaxy?
Okay, we live there.
Okay, that's our home. As the universe expands, every other galaxy gets farther away from us.
In ordinary expansion, each galaxy stays the same size. But if you have super accelerated expansion, then the galaxies themselves can each expand, which is sort of what's happened here.
If I could blow it up fast enough to depict a big rip, then the balloon would explode. That's like space-time not being able to take it and coming to an end. So instead, we'll just pop a hole in the balloon. That's the big rip.
According to Caldwell and Kamienowski, the universe has no hope of surviving the Big Rip. They've even come up with a countdown to this apocalyptic event.
The Big Rip kind of rolls up its sleeves and progressively takes apart the universe layer by layer, working from the outside in, going from the largest scales to the smallest scales. 1 billion years to pull apart clusters of galaxies, then hundreds of millions of years to pull apart galaxies themselves, and then down to the size of a solar system, we're talking hundreds of thousands of years, and then to tear apart the Earth itself would take less than an hour. It's kind of interesting to think about what that would look like. If I'm in my protective capsule watching things happen, I would see this wall of darkness that starts coming towards us. I would no longer, at that point, be able to see any stars. The Earth, layer by layer, will be peeled off and ejected away.
Everything in us, the molecules that hold us together, would get ripped apart, and every atom that makes up your body would fly off to infinity in a very short period of time.
Fortunately, mankind doesn't need to lose sleep over the Big Rip. Caldwell and Kamienowski estimate that it will climax 50 billion years from now, when the universe is over 3 times its current age.
What's really fun for us is to try to figure out whether this is actually what's going to happen, to paint the science fiction scenario of what might happen and to think what might happen to us.
Deep space threats are real. Some could harm us tomorrow, others in the far future. But one thing's certain, something will terminate Earth and probably the entire universe once and for all. It's only a matter of time.
It's useful to sometimes think about how fragile our life is here on Earth, that maybe we aren't going to be here for eternity. Maybe there's a hope, but the way it looks, the universe just ends, and that's it.
$400 million miles from Earth exists a mini solar system of over 60 moons rotating around a powerful planet of gas. Its flowing colors and spots hold strange beauty, but contain violent storms and jet streams. Could this big, bright ball of weather have been the Star of Bethlehem? Could one of its moons harbor life beneath its icy crust?
We expect that branches of life will exist on Europa, just simply because water is the key feature.
I want to go ice fishing on Europa. Cut a hole, put a submersible, look around, see if anything swims up to the camera lens and licks the camera. That's what I want to do.
And does our own planet owe its survival to this massive cosmic magnet? Jupiter, the giant planet. Jupiter is 500 million miles from the Sun, a giant sphere of intrigue. This churning ball of gas may look like an artist's rendering, but it's the real thing.
Jupiter has the most exotic weather patterns we've ever seen in the solar system.
Jupiter is 84% hydrogen and almost 14% helium, the two lightest and most abundant elements in the universe, rolled into a mammoth mass.
This thing is 11 times the diameter of Earth, and you could take 1,000 Earths and stuff them inside Jupiter comfortably.
Jupiter really is the lord of the solar system. You know, about 70% of the mass in all the planets is in Jupiter. If you're talking about planets, Jupiter is the big boy in the block, and it really does rule the roost.
Jupiter is the largest planet in the solar system, visible to the naked eye. A day is only 9.9 hours long, and it takes 11.86 years to orbit the Sun. A 150-pound person would weigh 350 pounds on Jupiter. There are thunderclouds made of ammonia, sulfur, and water. Exploring Jupiter would be NASA's most daring mission to date. It's a hostile place with temperature extremes from frigid to fiery. Its electromagnetic radiation is intense. It could kill a traveler to the planet in an instant.
We would need heavy lead protection, and that's very difficult to lift off the ground. So we have some difficult engineering challenges to actually bring human beings to the planet Jupiter.
A landing on Jupiter is not going to happen. Jupiter itself is a very gassy planet. It's made of gas, so you would not have a solid surface on which to land and walk around. You would just keep descending through the clouds and then be eventually crushed by the pressure of Jupiter's atmosphere. That make a human trip to Jupiter quite a challenge.
But what if we could go there? Dr. Andrew Ingersoll is an authority on the planet. He takes us for a ride.
You need a special kind of balloon because Jupiter's atmosphere is hydrogen. Hydrogen is the lightest gas. A helium balloon would sink. So the only thing that'll float in a cold hydrogen atmosphere is hot hydrogen. And so you need a hot air hydrogen balloon.
For the past 10 years, NASA has been developing ultra-long duration balloons for robotic exploration. And as we all know, heating hydrogen is a tricky thing. But just how this behemoth was born is a puzzle.
The formation of Jupiter is the greatest mystery associated with the planet.
Some believe Jupiter may have been a failed star. Like the Sun, it had the right ingredients, hydrogen and helium, but not enough mass to create the internal pressure and temperature necessary to have nuclear fusion. So it became a planet instead.
The thought is that there was this cloud in the galaxy that had the same composition as the Sun. Gravity and some stuff was left behind, and that stuff became the planets. And the majority of that stuff became Jupiter, and the rest of course, went into the Sun, and then there were a couple of little tiny leftovers like Earth.
Jupiter's spinning gases attracted like elements and over time grew bigger and bigger in the process. Almost like an oyster creating layers around a grain of sand to make a pearl. What gases and solids Jupiter didn't ingest, it spat out into space.
So Jupiter is like your big brother in the schoolyard, protecting you from bullies that might wreak havoc on your existence.
I tend to think of it as more of the cosmic frisbee guy. It's grabbing things out of space, and it's also tossing them back out. It ends up keeping those objects from the inner solar system where Earth and Mars and Venus are.
By cleaning some of the debris up, kicking some of it out, shooting some of it into the sun, where it'd be lost forever, Jupiter cleaned out a path that the other planets could exist in some sort of peace.
So dominant is this Frisbee phenomenon, Earth may owe its very existence to Jupiter.
It influences the courses of comets and even some meteors and asteroids, so that over the eons, the fact that Jupiter is there helps dictate what happens in the inner solar system. So really, the presence of Jupiter may be one reason why we have life on Earth and habitability and be able to have the Earth a nice environment instead of getting pummeled by so many comets.
There is no greater proof of Jupiter's power play than what happened during a 7-day period in July of 1994. A comet called Shoemaker-Levy 9 barreled toward Jupiter. Once under Jupiter's influence, there was no going back. A missile was on a crash course with a ball of gas. Jupiter's gravitational pull was so great that it broke the comet into small pieces that came in one at a time. These pieces assaulted the planet at a speed of 37 miles per second.
When you have a missile going at supersonic speeds, you get a shock. You can see sort of clouds of material being jetted up from beneath where it landed.
One of the fireballs generated by the collision with Jupiter's atmosphere flared 1,800 miles into space. Had Earth been in the projectile's sights, the effects of such a smash-up would have been catastrophic, to say the least. Similar to the event that wiped out the dinosaurs.
The energies that were released in those fragments hitting was larger than, on the order of 10 or 20 times more powerful than the entire world arsenal of bombs.
Take Jupiter out of the picture, bring this giant comet into the inner solar system. Where would it have gone? We have no idea. Might have crashed into Earth. If that comet had crashed into Earth, things would be a lot different around here.
The experts believe that comet strikes on Jupiter may be 8,000 times more frequent than those on Earth, thanks to the Frisbee effect.
But it cuts both ways because Jupiter has no value system. When it sees an errant comet, it may attract it and swallow it up, but where it flings it is anyone's guess, and so errant comets can be flung in towards Earth, they can be flung into the sun, and they can be flung out of the solar system.
There's a reason the planet rejects some of the space junk heading its way.
Jupiter, being the biggest object in the solar system, has the most gravity. And so other objects, little fleas that have their own trajectory flying by, are bent from where it would be towards Jupiter, and usually with an acceleration. And that acceleration can cause it sometimes to just be ejected completely.
No earthly Frisbee thrower can match Jupiter's flinging force. It is much faster than any bullet ever known. It rejects things at a rate of 30 miles per second. Jupiter's wonders are hard to fathom. They've captivated man for centuries.
Prehistoric humans realized that it was moving among the stars, and it was one of the planets that they appreciated. And Jupiter was the king of the gods, after all, in Roman mythology.
And there may be a biblical reference to Jupiter.
Ever since I was like 5 years old, I remember people, oh, that was the Star of Bethlehem. And whether or not it really was, obviously we have no way of knowing. But it's not clear whether the star that was talked about is a single star or whether they meant an astronomical alignment of objects in the sky. We don't really know.
It's known as conjunction in scientific terms. According to researchers, Jupiter and Venus did appear as one large star-like object in August 3 BC and would have been visible in the eastern night sky. But it was Galileo, the father of modern astronomy, who made the first recorded sighting of the Jupiter system.
In the early days of 1610, only about 18 months after the telescope was invented, he got his own telescope and he looked at Jupiter.
In 1665, Jupiter's most fascinating feature was discovered. Its giant red eye was actually the eye of an enormous storm, unlike any experienced on Earth. This one has raged for at least 300 years. This weather disturbance is a meteorologist's dream.
Jupiter's Great Red Spot is truly huge. You could take Earth and fillet it out and it wouldn't even really cover the spot.
This storm is the hugest storm in the solar system. Just to give you a feeling about it, it's about 12,000 miles. And the Earth is only 8,000 miles wide.
And the winds blow quite fast around the edge, but it's calm in the center. It's not like a hurricane, which has an eye and very fast, turbulent winds in the center. The red spot is rather calm. If you were in a balloon, it might be a pleasant ride, as long as you avoided the small-scale stuff like the thunderstorms and the turbulent places. Even though you'd be going very fast, it might be quite calm.
Fast as in 350 miles an hour. The fastest wind ever recorded here on Earth was 231 miles an hour. But is it an Earth-like storm?
It's a giant collection of clouds roiling around, lightning going on. So we can only model and imagine what kind of precipitation, but condensation in the form of condensed vapor of various gases.
This famous red spot is a high-pressure system that can take 10 days to complete a rotation.
It's really a backwards hurricane. It's called an anticyclone. That's the name for it. So it goes backwards from the direction of a typical hurricane.
That's not the only curious thing. Hurricanes as we know them need water in order to form. There's no water engine in the red spot. This never-ending weather system is feeding on something else. But what? Jupiter's Great Red Spot is something like a non-stop hurricane. It's a colossal storm, complete with violent wind and lightning. Storm chasers would love to go running after it. Dr. Tim Dowling of the University of Louisville is in the hunt for similar phenomena here on Earth.
The red spot is, think of it as a huge extra lens or egg shape of mass. It's just an enormous thing. It sort of quiets down the fluid. It presses it down into the hotter interior so you don't get thunderstorms. But if you go on the edge of the red spot, especially northwest, you get some of the most horrific thunderstorms you're going to find on the Jupiter.
The spot doesn't have an eye, and it isn't fueled by water. There's no ocean over which it forms. What then keeps it going and going?
I've always likened it, in my own view, as like a mini volcano inside of Jupiter.
Actually, an atmospheric volcano. Dr. Baines believes that warmer gases rise from heat deep within the planet. While trying to escape, they create a vortex.
So for some reason, I believe there's extra energy right there.
But it's just a theory. Science is left without answers to that question and others. Current theories cannot quite explain why the spot is so well formed and why it stays in one place. The plot thickened over the years as scientists learned even more.
It became a deeper mystery because instead of everything just sort of smoothly going around the red spot, we saw this turbulence, and there were smaller scale structures that would come and go every day, and it was chaotic and turbulent, and yet the red spot just existed and sailed on.
Jupiter's storms aren't limited to the Great Red Spot. Cloud decks 3 layers thick hover and cover the planet.
If you were inside the atmosphere of Jupiter, you would hear very loud thunder. In fact, the thunder actually travels 4 times faster on Jupiter than it does on Earth. It's about 3,000 miles an hour. The rain falls twice as fast on Jupiter. The charge separation that pulls the positive charge to the top of the clouds, the negative charge to the bottom of the clouds, is twice as efficient on Jupiter for that reason alone, because the rain is falling so much faster. Towers of cumulus convection that you see on Jupiter are 3 times taller. They go up 30 miles, whereas on Earth they go up 6 or 7 miles.
It would be impossible to survive within the Great Red Spot with its 350-mile-an-hour winds. By comparison, Hurricane Wilma, which had the highest recorded winds of any earthly storm, slammed into the Yucatan Peninsula in 2005 with barely a breath. 175-mile-an-hour blasts. Our weather is simple. Jupiter's is complex.
Now on Jupiter, you just basically have one storm system sort of stacked on another, with lots and lots of room. Basically, these are the storms in their natural state.
These storms move relentlessly within Jupiter's other distinct feature, streams of fierce jets that continually circle the planet. Scientists are only beginning to understand what they are and where they come from.
There's a massive eastward flow of material, and that means material's flowing more than 1.5 football fields per second. That's really moving. You don't want to be in that.
29 other belts and zones of varying widths extend outward from there. They are what give Jupiter its characteristic appearance. They move in alternating directions, some eastward, some westward.
They're much smaller scale, the high latitude jets, than the equatorial one. As far as in comparison to Earth, these are massive, super fast, high speed winds, and yet they're just going back and forth.
The planet's rotation rate has something to do with it. Jupiter generates a lot of energy because it really moves.
So the very nature of the spinning causes Jupiter to not just have one jet stream, but many jet streams going in opposite directions along the planet. And so you can see these zones. So what you have is an exaggerated version of Earth's basic weather pattern.
The spectacular swirls are created in surface clouds where the zones meet. It's believed that the energy ultimately powering this belt phenomenon comes from intense heat deep within. It's not unlike something we see every day.
You boil a pot of water on the stove, it'll start bubbling, and bubbles come up from the bottom and try to get out, trying to circulate that water, that currents around. So that's the same thing inside Jupiter. We have gases and liquids down there that are trying to get the heat out.
There are basic questions, basic pieces of physics to go after, to explain. Massive jets. Shouldn't we be able to explain that?
Earth has just one primary jet stream. It moves eastward, and another major flow that blows westward, the trade winds. Triple that power, and you've got the jet streams of Jupiter.
totally different from Earth. And yet, I should be careful, not totally different from Earth, just Earth on steroids.
And you ask yourself, wow, if I understood what's going on Jupiter, Earth would be just a piece of cake.
Jupiter's mysteries aren't limited to the planet itself. Some of its most intriguing elements are circling around it.
Jupiter's got several dozen moons that are big enough to be seen. It's probably got a lot more that are too small to be seen with current technology, and no doubt in coming years more will be discovered.
Some of the moons are almost the size of some planets. So really Jupiter is its own little solar system.
Thanks to its incredible gravitational pull, it sucked in asteroids along with other space debris. For the most part, there is order, but there are some erratic moons in orbit around Jupiter. It's managed chaos.
You can imagine a bunch of runners in a track in their lanes that each runner stays in. They won't collide. That's kind of how celestial mechanics.
Each moon holds its own fascination. 4 of Jupiter's prominent moons were discovered by Galileo. He first observed that they revolved around the planet. They are named for Jupiter, the god's lovers.
The first major moon you come to is Io, which is this very active place with lots of volcanoes. It's almost all the time going off.
Shooting out magma 200 miles into space. Io is a wonder, pockmarked with over 100 volcanoes, some the size of California, which seem to turn themselves on and off. Ganymede is the largest moon in our solar system, 5 times the size of Earth's moon. Callisto is the most heavily cratered. It has clearly taken a beating in its lifetime. Then there's Europa, the ice queen to Jupiter's king. No one knows its makeup for sure.
It looks like a cracked egg. It really looks like the whole thing had liquid water on it at some time. It froze and it cracked. And we believe that these patterns are due to tidal forces that crack it.
As alien as Europa seems, it is smooth and glassy in some spots, hilly in others. In fact, it is remarkably similar to one of Earth's frozen wonderlands.
There is a lake in Antarctica called Lake Vostok that scientists think is an analogy to what we see in Europa. Antarctica has a huge thick ice crust, and underneath there is this liquid lake, and we think that this may be very similar to the water ice underneath the surface that we see on Europa.
You go down through that crust, you go through the ice enough, you'll get liquid water, and we are very convinced that there's liquid water down there. It's the only place that we know of besides the Earth which has liquid water in large bodies that have been there, we believe, for more than 1 million or 2 million years.
And where there's water, could there be life? Jupiter's moon Europa is bursting with secrets. It may even have warm thermal vents deep below its frozen crust.
In fact, an immense ocean, bigger than the Pacific Ocean, worth of liquid water down there that's just sitting there for things to happen to.
The presence of water means one thing. We may not be alone.
I want to go ice fishing on Europa. Cut a hole, put a submersible, look around, see if anything swims up to the camera lens and licks the camera. That's what I want to do.
One scientist is planning just such a fishing trip. At this outdoor lab near Austin, Texas, hopes are hanging on a little robot.
This is designed for exploration in unknown territory, completely unknown territory, and the search for biological life.
It's a deep phreatic thermal explorer, or DepthX for short. Its proving ground right now is a local quarry. And there are big plans for its future.
If everything went according to plan, you would launch around 2016. It would be at Europa by 2018, and by 2019, for certain, we know whether there's life off Earth. That's the game.
DepthX is the brainchild of engineer Bill Stone. He and a team of scientists have staked their reputations on it. They've spent 6 years developing the concept and building the prototype. It's part of an ambitious project that would see it carried into space, sent through 6 miles of ice, and into Europa's ocean.
To divide it down into all the various vehicles, you have a parent vehicle which takes you to orbit around the moon Europa. There will be a lander. It'll land on the ice. Then there's a second stage of the lander which melts its way through 3 to 5 kilometers of ice cap, and then at that point you kick out the third stage. We need a fast-moving device that would be sort of torpedo-shaped, most likely nuclear-propelled, and that would drive for thousands of kilometers around the central ocean of Europa.
Is that really feasible? NASA thinks so. The space agency is on board with money and its blessing, an investment in the search for life. If life exists on Jupiter's moon Europa, could it walk, talk, or fly?
It would be little viruses or, maybe at best bacteria. We would expect only to see primitive life forms, but they might be similar to things that we see on the Earth, but we just don't know.
Scientists are encouraged by the discovery of strange and hardy life forms found in the most inhospitable places on Earth. Tube worms, for example, survive and thrive in total darkness. Extreme pressure isn't a problem. The creatures were discovered in 1977, several miles below the surface of the Galapagos Rift. They exist in water near superheated thermal vents. It's believed that these very conditions, darkness, high pressure, and hydrothermal vents, are present on Europa.
You could have hydrothermal vents kicking up warmth and nutrients down near the core of Europa, and that organisms would have fed off of that material just like they might have in the early Earth.
And while tube worms might not be lurking beneath Europa's icy shell, something else could be.
Its microbial life is the bulk of life on Earth. We expect that branches of that type of life will exist on Europa, just simply because water is the key feature.
Finding it consumes scientist Bill Stone. His DepthX may answer a question that excites seekers of knowledge.
Can we have the robot behavior look for signs of life and then try to collect a sample based on what it's sensing?
Stone's baby is in its infancy. At the same time, it is futuristic and advanced. It's a high-tech toy like no other that might show our world what another is all about. first contact with extraterrestrial life may be on Jupiter's moon, Europa. The DepthX robot, or more accurately, Hydrobot, is being designed to ultimately think, move, and explore without help from man.
And that is all to be done by the robot itself. We're not going to be guiding it to do that. That's going to be a big step forward in what we would call robot science autonomy.
It's a real-life HAL, the star of a new space odyssey.
Where it's literally hit a button and let it dive below the surface, and we won't see it again until it tells us what's down there.
DepthX will be able to extract and analyze samples on its own as it navigates the ocean.
This little tube you see down here will pull in water samples and store them in 1-liter bags. We have 5 of them on board. But before it does that, it actually powers through a series of micro pumps over here on the left and brings it into an onboard microscope. And that microscope will take images of what's in the water down to about 5 microns. So we can see most of the typical types of microbial life from 5 to 200 microns on screen. The robot will use that to discriminate, to determine if there's life, and then grab a sample.
DepthX and its systems must be made smaller to work in space. And it still must pass trials under ice flows.
We are testing this in Antarctica to make sure it all works totally under ice.
The question of life on Europa is probably the big unknown, because that would change our whole view of the universe, basically. I mean, if this little moon sitting out there in this hostile environment of Jupiter can have life form on it, that means that probably tells us that life is almost everywhere.
The science is there. I mean, I think searching for life is one of the most compelling things that we can do as not only as scientists, but as a race, as human beings.
It's a giant leap, and not just for mankind.
No, for robot kind.
Of all Jupiter's imposing features, none is more impressive than the one you cannot see. It's bigger by far than the Great Red Spot, more dynamic than the bands of jet streams, and as lethal as any killer known to man.
You have one of the most powerful radiation environments in the solar system, aside from the sun.
The magnetic field of Jupiter is the largest entity, I believe, in the solar system.
It is a bubble 450 million miles long, buzzing with electrically charged particles. It's Jupiter's magnetosphere.
The sun's sitting here putting out the solar wind, and the solar wind is charged particles of protons and electrons.
These particles flow along at 1 million miles an hour.
And Jupiter basically captures these protons, electrons, all these charged particles like electrical currents, and it has it then in space circling around Jupiter.
No word in the English language accurately conveys the enormity of this phenomenon.
The magnetosphere of Jupiter is the biggest object in the solar system. It's a lot bigger than the sun.
Comparisons are the best measure of this mega mighty wonder.
If it were visible in the night sky, it would be many, many times bigger than the moon. It's enormous, even though it's 5 times as far away from Earth as the sun is, it still would look immense in the night sky.
If visible, it would take a familiar form, a windsock. There's a rounded section facing away from the planet in one direction, with a tail flowing out the other. this windsock reaches the outer orbit of Saturn. Power plant Jupiter generates up to 10 million amps of electrical current.
The biggest planet in the solar system can conduct electricity all the way through it and around it.
This conductivity creates a phenomenon we can see when the excited charged particles escape.
Jupiter has auroras because when those particles leak in and crash into the upper atmosphere, it glows, and just as Earth has auroras.
These ghostly auroras are 1,000 times more powerful than Earth's northern and southern lights. They measure up to 1,200 miles across. If you could stand under them, they'd fill the entire sky, moving at lightning speed, 10,000 miles an hour. Jupiter's magnetic field is a monster, and it roars. In fact, it's speaking to us right now. Jupiter, the giant of the solar system, has something to say if you're listening.
We can hear what we call lion roars because it has this roaring sound. We can hear whistler modes. We can hear hiss and whistles that are going pew, pew, pew. And these are all indications of dynamics, things that are happening in the magnetosphere now.
If you find yourself driving on a dark desert highway, your AM radio might just tune in to the strange sounds of Jupiter's magnetosphere. The bursts are as short as a few seconds and as long as a couple of minutes. They come and go every hour or two.
Most of it sounds like static, but every once in a while you pick up something that sounds like a rising tone or a falling tone.
Some listeners have described audio spasms that sound like woodpeckers or waves crashing on the beach. The noise is disturbing. But just why the planet was talking remained a mystery until Voyager 2 passed through the outer magnetosphere in 1979.
Nobody really understood for a long time how those signals were generated. So that was one of the things that was on my mind when I got interested in Jupiter. What in the world was going on with these radio emissions?
It is one of the few secrets finally surrendered by Jupiter.
And that answered some questions, but it raised new ones. And I think that's the way it should be. If you don't have questions, it gets kind of boring and dull. So I think that the fact that the planets don't give up their secrets easily, or the universe doesn't, that's part of the game. It's what makes it interesting.
Jupiter keeps astounding and confounding scientists. One surprise came in 1979 when it was discovered that Jupiter has a ring. It's nothing on the order of Saturn's. Still, it's another feature that fascinates.
All of the giant planets have rings, probably left over from when the planets formed. And the moons coagulated out of the gas that was there, and then it could be a failed moon. So Jupiter's ring comes from material being knocked off of one of the interior moons. So it's dust that's collected from material that's coming in from outside moons.
The ring is slowly growing as new material flows into it. And there's a whole other side to the planet that remains a mystery. Why do these storm spots keep forming? There's the dark spot, for example. Glimpses of it were first spied in 1997. It appeared to be a huge, ominous cloud, twice the size of Earth, hovering above Jupiter's North Pole. There's a host of other spots, too.
There are other sort of smaller cousins that have come and gone. There were 3 ovals about half or a third the size of the red spot. And they sort of occupied the same latitude band in the southern hemisphere. And they'd been around since the 1930s. And amateur astronomers saw them form. And they were around till the late 90s. And 2 of them merged with each other. And then the remaining 2 merged, and now there's 1.
And it keeps transforming.
It turned red about 6 months ago, and now we're calling it the little red spot because it turned color. Now, why did it turn color is a big question. So there's chemistry going on, or some type of extra dynamics that's going on that just kicked in, and we need to start studying that.
Jupiter is a hostile and restless planet. Its giant gaseous body and violent storms make it one of the most alien environments in the solar system. Even though it is 500 million miles from us, we may have more in common with our cousin planet than we think.
I think the lesson to learn from Jupiter here is whatever's going on in our climate and our weather patterns here on Earth, Jupiter has more of it. But Earth is not an island, and there are better examples of what's going on Earth than even Earth itself.
For scientists, Jupiter is the king of many questions concerning our solar system and could possibly hold the answers.